I'm going to go through this sort of evolution of the local stormwater management philosophy practice very quickly, but this is the important stuff. This is where I think people should pay attention. And this is sort of the practical applications of the philosophies that have evolved over the last 30 or 40 years. I don't expect this is any different than other jurisdictions. I think we're all in the same boat here. Through the 90s, the philosophy was to put, pardon me, up until, I think I'm a little different than King here. I think that it's, maybe I'm a little slower. But I think it's been a while, quite a bit longer, that sort of the big pipe liability concept was out there. Stormwater as a liability rather than an asset. And I think that's really up until, in my mind, in my practice, up until maybe 15 years ago, that's the way we used to think. And then in the 90s, you know, we started thinking about detention ponds, stormwater management concepts. And so this is a typical pond, built actually in conjunction with a large commercial development. This was right after it was constructed. It now looks dramatically different. But it's still an engineered pond, right? It doesn't fit the environment very well. It doesn't fit the landscape very well. It's very rectilinear in shape. It's been planted, and if you drive by, you can't see the water anymore. But it is representative of something that doesn't really fit nature that well. So these ponds evolved insofar as we realized that the continuum of storm events was what we needed to think about. As engineers, we're very much regimented on typically in terms of a 2-year event, or a 5-year event, or a 10 or 100-year event as being of some significance. But in reality, we've got to think about the continuum of storm events, and particularly the smaller ones, because as you've all read in the guidebook, the idea here is that, you know, the vast majority of total annual rainfall occurs very, very low intensity, very frequent events, and that's the rainfall that we consider, not just the big monster storms that might blow up the storm sewer system down below. So there, enter the Provincial Stormwater Planning Guidebook, which was circa 2003, I think. That's about right. So I mentioned groundwater recharge is one of the fundamentals now, rather than just storm ponds. And who can tell me in the audience what's the matter with this picture? It's in hard pen, that's right, I don't know who said that, but you're down on the mark. So I'm going to get into this a little bit later, but the idea here is that if you're recharging the groundwater table or trying to recharge the ground, you got to be careful, right? You can do one of two things. You can do something that's not going to work because you're setting drain rock and porous material and perforated pipes into impervious soils, so this will fill up once it stays full, right? Or conversely, and perhaps more problematically, you can put water into the ground where it shouldn't have gone, and it's going to pop out somewhere you don't expect and cause somebody a lot of grief. And so, thus the concepts of hydrogeology and not just simple surface hydrology have become far more common in the design of these kind of facilities. So that's what I'm getting at, is that this is no longer a simple science of just Q equals CIA over 360, right? A lot of the guys in the room know that formula, and it doesn't apply anymore. It's just not giving you the whole equation here. So this is a simple oil-water separator. This is getting into water quality, which is another fundamental of the guidebook. We talked about quantity and quality, right? Quality being, of course, very important to the health of the streams into which this water is distributed. You can tell me what's wrong with this one.
Not hooked up.
It's not hooked up. That's right. I don't know if this is actually true or not, but I don't see a bypass here. And so, a little techie thing, but these oil separators, this is a really small one. It was a small installation I put. But if it doesn't have an overflow or a high flow bypass, it won't work, right? The oil will collect in there, and then the first heavy storm will just get blown out. So it'll catch it for a little while, and then the big storm is just going to blow it through into the ocean anyway. So, as I say, you know, the management concepts evolved into water quality as compared to just quantity. This is an artificial aquifer in behind a large commercial development. The idea here is that there's a perforated pipe up the middle, and the roof water from these, 2-3 acre buildings are just monstrous. Drains down into this pipe, recharges this thousands and thousands of cubic meters of sand, which gradually works its way into the watershed slowly. So water balance and the water cycle became things that engineers had to start thinking about rather than just peak flows. And we begin to start listening to nature rather than trying to control it. I think that's really a fundamental here. This is a really basic thing, but it's called a bioswale, right? Everybody's heard of bioswales. Not particularly sexy or difficult to conceive of. It's just a strip. There's no curb along the edge. It's a strip of grass beneath which is a large volume of porous material that will accept some water. So the total volume of water, this is another fundamental here. We're not talking just about chopping the peak off of peak flows, peak flow rate. We think about flow rate versus volume, right? That's the fundamental of the water planning guidebook. That volume becomes something you got to think about. But after you develop, no matter how hard you try, there's going to be more water leaving a given site than there was before, more total volume. And what the scientists have been telling us is that, because there's applied science which is applying this, right? They're telling us that the volume of water that leaves a given site actually does a fair bit of damage. The total volume is important to keep in mind. And that's the idea of recharging your groundwater table and trying to minimize that rapid total volume of runoff, even if it is a lower flow rate. So when we get into all these sort of BMPs, and everybody's talking about BMPs, the one that I think is the most important here and the least utilized is this 300 millimeter topsoil idea. That's pretty simple to enforce. The areas that remain pervious, make sure they've got some pervious soil on them. Don't let the developer get away with 2 inches of black soil with a bit of turf on top. Force them into a sponge there, and that'll have an enormous impact on these low-intensity, very frequent events. So yeah, catchment-based thinking as compared to just what do I do with my site? How do I drain my site? How do I get on with life? How does this site impact the catchment overall? And one of these buzzwords, effective impervious area cropped up maybe a decade ago, and really important concept here is that if you can just break the curve line, for example, and allow this water that leaves the road to slow down a little bit, it will have a big impact on the watershed and the health of the stream. So I think it's true to say that, as I started this discussion, that sort of we're reacting to some degree, but an informed, enlightened, and very knowledgeable public is having a large impact on the way we do things. And I'm happy for that. Because as working for some perhaps less scrupulous land developers, for example, who are looking strictly at the bottom line dollar here, I look to the regulators to force it on them, to put it bluntly, to ensure that the watershed is maintained and cared for. So, and I think we're heading in that direction and we're doing a good job. So we're getting to the point where rainwater is now an asset to be managed, not a liability to be managed. And I know in the next, I believe in the next session, or perhaps the last one, Jim's going to be talking about the evolution of the water balance model and now using it in sort of watershed context as compared to the site-specific utilization that we've dealt with in the past. And lastly, sort of sustainability principles in civil design, and that's a whole new realm we could talk about for several hours, so I'm going to just pass that.